Welcome to the Grain Farmers Ontario GrainTALK webinar series. Today, we're going to be talking about the penalty of poor rotation. With us today, we have Cameron Ogilvie, who will be the moderator, and Cameron's with Soils at Guelph. We'll have Deb Campbell with us, a certified crop advisor, and Dave Hooker, researcher, University of Guelph. Thank you for attending.
Thanks, Marty. So my name is Cameron Ogilvie. I'm the Knowledge Mobilization Coordinator for Soils at Guelph, which is an initiative of the University of Guelph to promote sustainable soil management in Ontario by connecting researchers and farmers and farm advisors and other groups to talk about the importance of soil. Thanks to GFO for the opportunity to host this webinar and one that's going to follow up on it. We get to celebrate something special in these two webinars. This year, 2020, is the 40th and the 25th anniversary of the Elora and Ridgetown long-term crop rotation and tillage experiments. So there's 65 combined years of agronomic research in two Ontario growing environments. And so as our industry is having conversations about what sustainability in agriculture looks like, these long-term experiments are invaluable. It's really hard to state how important these are. Before we jump into what we've learned from these two experiments, want to make some acknowledgements. First of all, the Elora and Ridgetown Crops Research Centers are 2 of 15 stations that are owned by the Agricultural Research Institute of Ontario, and they're managed by the University of Guelph through the Ontario Agri-Food Innovation Alliance, which is a collaboration between the Ontario government and the University of Guelph. So this research is partially funded by the Ontario Ministry of Agriculture, Food and Rural Affairs through the Ontario Agri-Food Innovation Alliance, as well as through Grain Farmers of Ontario and a number of other funders over the course of these experiments. I want to briefly introduce you to Dave Hooker and Deb Campbell. If you don't know them already, Dr. Dave Hooker is an associate professor at the University of Guelph and is based at the Ridgetown campus in southwestern Ontario. He specializes in cropping systems and agronomy and leads teaching and research programs. Dave also farms 500 acres near London, Ontario. Deb Campbell owns and operates Agronomy Advantage Inc. and lives on a farm just west of Dundalk, Ontario. She has a BSc in agriculture and agronomy and soil management. She's been a certified crop advisor since 2000, and she now serves as the current chair of the CCA Board of Directors. So thanks to the both of you for joining me today.
Hi, Cameron. Thanks for having us.
Thank you.
Yeah. Deb, we're having this conversation around rotation. As an agronomist, when I hear the word agronomy, like the first ideas that come to my mind are variable rate prescriptions or pest management strategies. Crop rotation maybe just isn't so flashy. So can you start us off by explaining, like, where does rotation fit into the conversation of agronomy?
Well, when I think of crop rotation, I think of it as being one of those underlying influencers on everything we do in agronomy. You know, you talk about pest management, a lot of that comes back to your rotation. You talk about fertility management. Again, rotation is inherently a part of that. And, you know, even so much when I'm, you know, building crop plans with producers, the first document we review is the crop rotation. So it all starts there. It's one of those fundamental layers that goes across everything we do in agronomy.
Okay, so if crop rotation is so fundamental, I'm going to share a slide with us. This is just looking at Ontario crops by percent of total area in Ontario. So starting back when these experiments started around 1980 and looking forward to today. So Deb, can you talk about some of the influences that have shaped the reason why today we don't necessarily see very diverse crop rotations in Ontario? We've seen a simplification and a narrowing towards corn and soybeans. So can you talk a little bit about what's caused this to happen?
Yeah, it's a very telling graph that certainly shows the large scale of corn and soybeans that dominate the Ontario rotation. you know, a shrinking of cereal acres over time, and you know, a less diverse rotation over time. Those are much smaller quadrants on this graph. You know, there's some reasons possibly, you know, that you could consider behind that. You know, a lot of producers tend to think that their corn and soybean acres are their more profitable acres. We hear that quite often, that wheat maybe doesn't keep up with the two big ones. You know, so that's influencing decisions on some of those seedings. That's a big part of it, certainly in the last 20 years of what's dominating those rotations. But I think we're, you know, I'd like to think we're maybe rounding the corner on cereals. We've seen some more stability at the very least in the cereal rotation, and you know, certainly a lot more consideration for diversifying the crop rotation and what that might mean on farm.
Yep. Yeah, there's a lot of cost benefit kind of decisions, I guess, that go into picking the rotation that's going to work best on your operation. Dave, I'd like to jump to you because this is a big part of why these two experiments began. Can you talk a little bit about that?
Exactly. So we started the Elora rotation trial started in 1980, as you mentioned, and Ridgetown 1995. And these research projects were started mainly because we had so many questions regarding rotation, crop rotation. And I like to look at these as a very important part of a system, as Deb alluded to earlier. And we had so many questions, like especially in the 1980s and the 1990s. The main reason why we had crop rotation back in the 1950s was because of like we didn't have synthetic fertilizers back then. We needed a lot of livestock. We had a lot of livestock in the systems. And as we evolved over time, more corn and soybean. But a lot of growers noticed that as corn and soybean increased in the rotation, the system or the soil began to change as well. And so these changes were noted, but it's very difficult to quantify these changes without data, of course. And that's one of the reasons why we started these, is just to generate a good solid data set so we can quantify some of these changes in terms of what crop rotation will be the best, what crop rotation will be the worst, and then maybe overlay, overlay some factors like tillage and crop rotation and nitrogen effects from these as well. And so the upper left one is an overview of the Elora rotation, and it was started in 1980, 8 crop rotations, continuous corn, alfalfa, continuous alfalfa, corn soybean rotation, and rotations that included winter wheat, oats, and barley, with and without underseeded cover crops. And then multiply all of those 8 different crop rotations by 2 tillage systems. So essentially we have 16 different cropping system combinations or treatments, and replicated 4 times. And so the Elora is, of course, a shorter heat unit zone than Ridgetown is. And it also is a different soil type. So at Elora, it's a silt loam. Ridgetown is a Brookston clay loam. That's where the trial is at Ridgetown. And the trial at Bridgetown, it has 7 crop rotations. And we don't have many forage crops in the Ridgetown location one, but we do have continuous corn. We have a soybean wheat rotation, and we have rotations that include soybean as well, and also with and without underseeded red clover. And then we have, similar to Elora, we have 2 tillage systems, like a no-till or a reduced tillage system versus a conventional or a plowed system. And then the unique thing about Ridgetown especially is our different nitrogen treatments that we have. Excuse me. So since 1995, on some plots, we have not applied any additional nitrogen fertilizer since 1995, except for the starter in corn. So we have very unique combinations there, and coupled with very like other extreme in terms of treatments, like very high nitrogen rates, high rotations. And so we look at all the soil effects between those two extremes. And then another thing that's important to note on these trials is that both are managed to try to reproduce exactly what happens or occurs on farm fields as well. And so for instance, we set up the rotation data. We set up our planters to be optimized as we go from one tillage system to the other. For instance, we try to duplicate what happens on farm fields.
Right, keeping things representative.
Yeah, that's right.
Yeah. So, 25 years later, 40 years later, we've got some numbers now. So I'm going to throw up this slide, which I already previewed for you, I guess. But Dave, can you talk a little bit about what we've been finding? This is from Ridgetown, but similar results at Elora, if I understand.
Yeah, that's right. Very similar results at Elora, and that's why we just love to talk about these results with Elora and Ridgetown combined, because really the same story is said by both locations, and it's very telling. It gives great support to the data. It's one thing to note about this, and I'm sure many have seen this slide before. It's one of my favorite slides, and it shows the effect of wheat on corn yields. And I should mention this slide, there's a no-till label underneath those 3 bars, and really that's a strip till system, so it's not a true no-till system, so it's a little bit of a mislabeling there. And so in the corn year, we do some fall strip tillage ahead of the corn, but in the soybean and wheat years, we do a true no-till system, except for a coulter that leads the double disc opener on the soybean and a single disc, I guess a double disc on the soybean as well. Mm-hmm. So, but in the no-till system, we have corn after wheat is the highest on both tillage systems. So depending on the tillage system, in the plowed system, we have a 17 bushel advantage of including wheat in a corn soybean rotation. So 17 bushel there. And then in the strip till system, we have a 6 bushel advantage, including wheat. Now, it's not always statistically significant, but it's quite consistent over time, those 6 bushels, even though that it's not statistically significant. I think it's very practically significant that it is 6 bushels compared to 17 bushels in the plowed system. And it's very interesting that the corn and soybean yield, in the corn and soybean rotation, the corn yields 165 bushel in the plowed system, versus continuous corn, we have 173. So right. which seems to be very surprising that in the plowed system we have at least a numerically lower yield with the corn and soybean rotation. And when we look at the soil in a corn soybean rotation in the plowed system, that soil quality is also amongst the lowest across amongst all of our crop rotations that we have. In the corn and soybean rotation, we have the lowest soil quality as well, and the yields seem to be reflective of that.
So maybe a bit of a reason why you're seeing a little bit better with the corn soybean in the no-till, just protecting soil quality a little bit better?
Yeah, exactly. So it's reduced tillage, so it's protecting some of that soil quality. And because soybean doesn't contribute much carbon like corn does, practicing no-till helps to preserve some of that soil structure and organic matter.
Yep. And it's a similar story with soybean. So here's soybean yield data too. Can you talk about this a little bit?
Yeah, the soybean data is very similar to both corn and or to both Elora and Ridgetown, and including wheat in the rotation on the plowed system there, the bars to the left, there's a 7 bushel advantage soybean yield by including wheat into a corn soybean rotation, which is very significant. So $7 bushel times, let's say $12 a bushel, that's $84 an acre just by changing the rotation, by including wheat in the rotation. And we say when we're looking at wheat in the rotation, we should consider some of these benefits that wheat provides to both corn and soybean yield. And really the same picture or same story occurs in no-till as well. So including wheat in a corn-soybean rotation, we have a 5 bushel increase in the no-till system as well. But interesting enough, when we just have soybean wheat rotation, we also have quite high yields. And so we have soybeans occurring every other year. So the frequency of soybeans is quite high, but yet the yields are quite high. So it's not really the frequency of soybean, I think, is a concern here, or that promotes high yields. It's the frequency of wheat in the rotation. It seems to have generate better soil quality, which increases the yield in both soybeans in this case and in corn as well.
Right. Now, Deb, I've been hearing that there can be some challenges with soybean into corn stubble. You know, as we're talking about these no-till systems here. Do you mind, I think I've got some pictures that go along with this. Do you mind kind of unpacking, I think Dave, you can unpack this a little bit too, but what's kind of the challenge that growers are having with soybeans into corn stubble?
Well, it comes down to residue management as our corn yields continue to improve and increase over time, you know, and our genetics. Part of that is from BT genetics, part of that is from stock stability, and you know, we're just finding it that much more difficult to be able to no-till into a high residue scenario. And you know, we're experiencing some stand loss, maybe occasionally even a replant. You know, the beans, you can see it quite distinctively here. They're a little bit slower to grow, a little bit shorter. You know, those early season soybeans that are no-tilled into corn just don't look quite as good. And there's a lot of concern around that. And you know, folks are looking for ways to overcome that differential. And you know, it's you know, we certainly would not want to have to be replanting soybeans in a scenario like this.
Right.
It's quite often maybe influenced by other factors as well, such as seed corn maggot or pest issues. But you know, we're working with systems that would include an early passive tillage, namely a vertical till type of system, or a high-speed disc, just to mitigate and overcome, improve the seed to soil contact that we would get in that no-till system, so that at the end of the day, when the combine gets in there, that line is invincible, and the results are very close to equal, and I think most producers would be happy with those results. So it does take a little bit of trial and error. There's no one tool, no one date on the calendar, you know, to get that early emergence in no-till on corn residue to the level that producers expect to see, but we're getting there. It's certainly a lot more consistent, and you know, using a diverse range of tools and practices to get there for sure.
Right, right. Dave, you've done a little bit of research on this as well. What have some of your findings been?
Our findings in this this kind of, in the early growth, especially in soybean, is that we, as Deb mentioned, we see tremendous differences in early growth between, so even like some nitrogen applied or sulfur applied to soybean, or doing some tillage ahead of you know, a no-till production system seems to really encourage early soybean growth. And Deb, maybe you can comment on this, but I find that growers are really turned off by the slow start that, you know, no-till soybeans have, that even though the yields might be very similar at the end, it just seems to turn a lot of growers off, you know, a straight no-till, anything to encourage the looks, I guess. Maybe it's maybe they're comparing looks, maybe the neighbors are talking, say, hey, your soybeans don't look very good this year, you're not a very good grower, you know, just because they don't look very good. And maybe you could just comment on that. It'd be interesting to hear your comment on that, Deb.
Well, you know, for sure, appearance is important. I don't know a single farmer that wouldn't agree with that statement. But at the end of the day, there are some side effects maybe that could interact with that slower growth. Perhaps weed control, you don't get to canopy quite as early, and an extra pass of weed control might be part of the effect from that. But I think, folks that have no-till soybeans and corn residue really figured out, they've learned to accept the scruffiness, slow growth of that early no-till. And really the measurement comes is how well is it doing at pod fill and pod set and the metric of harvest yield. So, but you're right, there's an optical piece to this, but a lot of these guys are certainly businessmen. Ladies and gentlemen are businessmen, and they're looking for the bottom line at the end of the day. And of course, there's some variety selection that can come into this as well that improves some of those early season prospects. So there's a lot to come into that early season growth window, and I do think a portion of that is even being driven by, when we seed cereals, we expect to be able to row it. We expect to be able to, 10 days or less. We want to be able to row those plants. Same with corn. I can row my corn today. There is something to that from a producer's perspective, if I can, that just, it means that emergence is there. It's satisfactory. Things are off to a good start. And we have to sort of step back a little bit from that for soybeans, I think.
Yeah, yeah, that's right. Well, on my farm, this is a tough decision that I have as well, because I know that going over the field with, let's say, a VT tool will probably delay planting a little bit. I don't have a huge employee, like just myself and my father, farming. And so I know that planting date is very important for soybean. And doing a tillage pass, $20 an acre and maybe $15 at least an acre. And of course, it would need to generate enough revenue, I guess, to overcome some of those costs. And so I need to think very carefully before I do any tillage before soybean.
Well, and just one more thing to add to that, if I can, it's not just about tillage. We're looking at residue management coming out of the combine or ahead of the combine with the headers that we're using, the distribution that we're using on the spreaders on the combine. So we're looking at that to improve our seeding the following year in soybeans. We're looking at, that's certainly part of it, is looking at other influencers there. How do we prevent this problem right from the beginning so that we're not even relying on the tillage pass, through the combine setup? And it's a multi-dimensional challenge.
Right. So amongst all those dimensions, I'm trying to, is there a simple message coming out of this conversation about soybeans into stubble? Should we stay the course? Can we, do we not need to be so concerned about looking through our crystal ball and wondering if the soybeans are going to rebound? Or what's your kind of final words on this whole thing, if you can provide some final words?
Well, I think from my perspective, when you find a system, whether it's the tillage, whether it's the harvest management, whether it's the variety selection that is satisfactorily overcoming these challenges, lock it in, and that'll suffice for a period of time until something else changes. With these systems, they're always changing over time. And it's okay to perhaps let go of the metric that we use, the benchmark that we use for emergence in soybeans, and slack that one off maybe just a little bit too.
Yeah, good.
Okay, so to kind of jump back to the rotation conversation, Dave, you talked a little bit about some of the results that we saw in corn and soybean yield, but there's also a bit of a story about yield stability in corn and soybeans in these different rotations. Here's another slide of some Ridgetown data. Dave, can you explain to us what we're looking at here?
Sure. So Bill, Dean, and I, we've been looking at these different yield stability metrics for a number of years. Of course, the more years that we have, the more combinations of environments that we have as well to tease these trends out. And so what we're looking at right now is Ridgetown data from 2009 to 2019. So we have 11 years of data. And we have hot, dry years, we have so-called cool years, and then optimal years. So an optimal year would be a year where, you know, temperatures are warm, crops finish their development in time. And so those would be, and that would be an optimal year. And also an optimal year would be associated with, you know, not many water deficits. So the rainfall was, you know, adequate or near optimal for those years. And it just so happens that we do have so-called optimal years. It may seem far and few in between that we get optimal conditions. And sometimes we just focus on the stress years or remember those stress years. So I think 2020 is one of those hot, dry years, at least so far, or up to the recent rain event, kind of a hot, dry year. And in these hot, dry years, we tend to see the biggest rotation effects on these hot, dry years. So a couple slides ago, just a few moments ago, we talked about, you know, the advantages of wheat in the rotation is providing, you know, so much corn yield, so much soybean yield. And we found out that, you know, these rotation effects are even bigger in some conditions, so in hot, dry conditions. So these are Ridgetown data. So if we just look at the graph cluster on the right, in a corn, soybean, wheat rotation, this is a rotation effect compared to continuous corn. So in a corn, soybean, wheat rotation in a hot, dry year, we see a 33% higher corn yield with wheat in rotation compared to a continuous corn scenario. So 33% higher yield in a corn, soybean, wheat rotation compared to a continuous corn situation. That is in a hot, dry year. And you notice in a cool year and optimal years, that rotation effect is still quite big, 16 and 24%, but it's not as big as in a hot, dry year. And we also notice that in a corn, soybean rotation as well, in the strip till system and no-till system. So 22% rotation effect of a corn, soybean rotation compared to a continuous corn scenario. So remember that in a no-till system, the crop rotation effect is even more important than it is in a plowed scenario. So as you reduce tillage, as tillage is reduced, the crop rotation effect becomes even more pronounced. And you notice in a hot, dry scenario, in a corn, soybean rotation, we do have 15% higher corn yield compared to continuous corn scenario in a corn, soybean, wheat rotation. But we have a negative yield with a corn, soybean rotation compared to continuous corn. And that kind of reflects what we've seen in that couple slides ago, where in the corn, soybean rotation, the corn yields were a little bit lower. And this slide reflects that as well.
Right. Deb, you know, as Dave's been mentioning, we're in 2020 is maybe one of these hot, dry years. What have you been seeing out in the field? Have you been seeing essentially this sort of thing with, you know, corn in fields with good rotation history and corns with bad rotation history?
You can certainly see it in the moisture holding capacity and the corn plant's response to that. You know, the tighter the rotation, the more moisture stress there is on the plants and heat stress. You know, a restriction possibly in root development, or, you know, it doesn't take, when you're experiencing 30+ degree day after day after day and extremely high rates of evapotranspiration, you know, it doesn't take much differential between, you know, having 5% more water versus another system. And you could certainly see that leading up to last week's conditions with the extended period of hot and dry, and producers were clearly observing that, you know, we have the potential in 2020 to have a very strong crop. It's early. We're maybe only halfway through the season, but a lot of folks are commenting on how good their crops look, and when there is a field, you know, that isn't up to par or holding on as well, you know, a lot of folks are looking at that to see why, you know, what's the difference on that farm. Yes, it's a different farm, different history, but, you know, is it tillage, is it rotation, what are some of the factors that are leading up to that? And quite often it is coming back to a farm that has not seen a cereal in the rotation for a period of time. And, you know, that's certainly coming to the forefront here.
Right. Yeah. So, you know, as we look into the future, we've got climatologists who are predicting that hot and dry years are going to become more common. Maybe a bit of a cheeky question, but Deb, is there anything else that can save us 30% yield in these hot and dry years? Is there any other tool in our toolkit? Or is it rotation? Is that the answer?
Well, I mean, there's not a lot that I can think of that is going to fill that gap for us, you know, unless Ontario is ready to start putting in pivots everywhere, and I don't see that happening economically either. Not that there isn't those conversations happening too, but I think before we look at establishing irrigation, reestablishing a multi-crop diverse rotation would be a first step by far to do that. I don't really know how else you capture 33% more yield just by that decision alone. It's a phenomenal response.
Right.
Yeah.
And, you know, this story is probably getting a little bit predictable right now. We're going to jump to a slide about soybeans. Same sort of thing. Dave, can you unpack this for us? This is from a study that was published back in 2015, and this is based off of Elora data. And maybe Dave as well, if you could just, you talked a little bit about what the no-till, reduced-till systems look like. The plowed systems, is this plowing every year, or how often does the plowing take place? And what kind of plowing is this?
Well, this is either moldboard plowing or chisel plowing.
Okay.
And but it's the plowing occurs all the time after corn in the plowed system, and all the time after soybean, except when wheat will be planted after soybean.
Okay.
All right. And so when after soybean, if in the plowed system, if wheat follows soybean in that rotation, then we usually one pass with a disc, one pass with the cultivator, and then plant wheat. So that would be the plowed system scenario.
Okay.
All right.
Yep.
So this slide that we're seeing right now, the soybean yield response, this is Elora data, and this has been published. And as you mentioned, this is the exact same stories that we had for the corn, and that is in hot, dry years, we have the biggest rotational responses. And so here we're comparing something a little bit different. We're comparing to the corn-soybean rotation. And so here we have corn, soybean, wheat. So this is at the one of the rotations at the Elora trial, 2 years of corn, soybean, wheat. And then we have another system, but the wheat is underseeded with red clover. So that's what that RC stands for after W. But as you can see, in hot, dry years, we have a 25% in the corn, soybean, wheat rotation. We have a 25% rotational response to soybean compared to a corn and soybean rotation when we have wheat in the rotation. So 25% when we have wheat in the rotation in hot, dry years, compared to between 5 and 18% increase in either cool or optimal years. So this is kind of interesting, I think, on the optimal side of things. At Ridgetown, when I did the same analysis at Ridgetown, hot, dry, and optimal years, they were equal at Ridgetown. The biggest rotational responses are in hot, dry, and optimal years. And this just gives, I guess, I think it provides the key to high soybean yields especially. And regardless whether it's in hot, dry conditions, optimal conditions, the highest soybean yields are produced with wheat in the rotation. Then adding red clover, underseeded red clover doesn't have tremendous effect on the soybean year, but it has more, red clover has more effect to the corn yield potential than it does the soybean yield potential. And that is the same story at both Elora and Ridgetown.
And when we're talking about these hot and dry years, you know, even taking this year, for example, with corn, we weren't necessarily into, like we weren't silking yet, so we weren't necessarily into the reproductive stages quite yet. And reproductive stage is critical for setting yield potential. Periods a little bit before that, somewhat. Do you want to have that conversation, Dave and Deb, a little bit about, you know, this year, maybe what would your predictions be about the weather that we've seen this year so far? Did it hit us in a bad time? A lot of this data is coming from years where, you know, we were particularly concerned about the reproductive phase. So what are your thoughts on that?
Well, certainly, you know, I find, sorry, Dave, on any given season, you know, you get into a weather pattern, and you tend to stay there for a period of time, prolongs. And yeah, we're in the vegetative stages. A lot happens later on in the season. You know, you could say we're not even at peak water demand. We haven't had full canopy here yet. But you know, even going back to our earlier discussion around, you know, how do we improve soybean yields? And, you know, I mentioned about tillage, and I mentioned about, you know, pre-tilling and instead of pure no-till and managing residue. I mean, you look at this graph, and why would you even do that? Just put the wheat in the rotation. Like, right. How do you add 31% more beans instead of focusing on the corn and soy and the early soy development? It's the wheat that's carrying that increase, especially in those hot, dry years. And, you know, we've talked about stability in yields, and yeah, that's very important. We want to have some predictability, absolutely. But producers aren't usually satisfied with stable over time. They want an increasing yield over time, you know, which typically means we need more water to get to higher yields. So looking at these systems, better water use efficiency is, you know, clearly one of the outcomes of having cereals in the rotation and a more diverse rotation here. So it's, you know, you look at these numbers and you think, wow, why aren't we across the board doing this? And it's quite a challenge to implement that full scale.
Yeah.
I like to look at these rotations like, well, some people compare adding having a more diversified crop rotation as having your money in the equity market. You know, there's a potential for greater return, but this is different because, of course, the equity markets are really associated with a lot of volatility, and this is just the opposite. So we get more stability, and you're generating better returns. You know, it's just worlds.
Yep. So we're seeing the benefits of wheat. You know, it would be great if we could see this. It would be great if we could see that, you know, original slide of the trend in cereal acreage in Ontario. It'd be nice if we could see that trend the opposite direction. Maybe what would you say to the person who's looking at this data right now and going, okay, so wheat is a great rotational crop, but I can't necessarily make money off of it. Maybe I'm going to get better corn soybean yields. I'm not sure how that's all going to come in the wash. What would you say rotational crop idea? Deb, maybe start with you.
Well, as you just mentioned, if the wheat is increasing the profitability on 2 out of 3 crops, perhaps it, there's something to be had there for sure. And I'd like to think that we're certainly seeing improvement in wheat yield. Some areas maybe more than others, but we're seeing a steady increase and incline on wheat yields over time. And as new varieties are out, and being able to plant wheat in a timely manner, and there's lots of management practices that have been well studied, well understood, moving us forward in the wheat part of the rotation, that it's not always the the ugly sister that doesn't fit anymore. It's actually contributing. And one of the challenges I see is seeing is believing, and we have really great data from these studies from Ridgetown, from Elora, and talking, Dave puts it in such simple terms that are really just quite black and white. However, for a producer to implement and measure this at home is quite a challenge. The rotation effect, it's multi-year. It's and perhaps they don't even have the equipment on farm to seed cereals, that sort of thing. So it's really difficult. If you launch a new variety, you can go out and test it in the next season. This one's a lot harder to test the outcomes on farm, and I don't think there's really an easy answer to that other than to get started with some cereals in the rotation and see what those outcomes are. But we have to figure it out. To me, that's the bottom line. There's too much to miss out on by not figuring out the cereal part of the rotation. So, navigate some stronger wheat acres in the province.
Right. Dave, how about you? What are your thoughts on wheat, a rotational crop versus a cash crop?
Well,
where's your money?
Yeah, wheat is it is no secret that wheat is my favorite crop. Obviously, it certainly sounds like it the way I'm talking, right? And but wheat is seems to be the crop that is most responsive to management. And as a grower myself, I'm just very encouraged or very excited to manage a wheat crop because it has so much potential. It has a lot of interactions with the environment, but we can manipulate wheat to have a great yield potential. And most often we're at the mercy of Mother Nature, of course. But of course, planting date, we know now that planting date is extremely important for wheat. And so we're thinking, how can we plant wheat even earlier, maybe after soybean? And so there's some techniques there that we can do. Every day, of course, is important. Fertilizer with the wheat, like phosphorus, in-furrow phosphorus placement, we have quantified that. There's new fungicides, new nitrogen strategies, and interactions with all of those system factors. It's just very exciting to manage wheat, and I think we need to do a better job now to quantify or intensify the wheat enterprise, and that will help to add to the additional benefits of to the corn and soybean enterprises as well. When we include all of those different factors together, I think it's quite exciting. The wheat enterprise is very exciting.
Right. Deb, could you go through some of those strategies to winning with wheat? What are a few of the key points that a grower would want to know to be able to improve their wheat management?
So hitting that optimum seeding window, which is almost always earlier than what we tell ourselves in the fall. It's usually quite a bit earlier than what we tell ourselves in the fall, and sometimes that means having the right strategy in the spring to have that appropriate window in the fall. So hitting the early seeding window is almost always the better option to have out there. I often hear producers say, well, I've seeded on October 35th and had a really good wheat result. And those one-offs do happen, but I really don't consider them the norm. And those early seeding practices are really important. Having phosphorus placement with the seed You know, this is a crop that we're seeding into cool conditions. Certainly not like what we're doing in the spring where we're seeding into warming conditions. So that plant needs all the help it can get to establish roots, and phosphorus, seed place phosphorus is critical to achieve that. And we see that time and time again with pictures from research plots, pictures from growers' fields where they ran out or they turned it off, and it's just night and day, the response that we see there. And then, you know, looking at those nitrogen strategies, you know, the early seeding and the phosphorus placement gets you through that wintering period. And you come into spring and, you know, in a lot of cases, we're using more nitrogen than we were, you know, 10 years ago. And the response is there. The return on investment is there for that additional nitrogen. You know, in some cases, we're using split applications. There's a lot of reasons around that, you know, helping getting the crop going in the spring. Not every one of those results comes back with additional yield, but some of those are environmental reasons and things like that warrant splitting those applications. And then, you know, the additive effect that we're seeing when we're using higher nitrogen rates along with fungicides, and you know, ultimately we have a denser, more consistent canopy in that May-June window. And that's part of where the profitability is coming from, is more heads per square meter, and keeping that canopy healthy, and so that we're actually filling as many kernels of grain in that period of time is absolutely part of the package. So we don't even think twice when we're planting a corn crop to have all the I's dotted and all the T's crossed from start to finish on the pre-plant tillage, or bells and whistles on the planter that make that seed drop just completely uniform, and timely weed control. In corn, we don't even think twice about that. We know that is driving yield, and
Right.
we want to be able to think that meticulously about those details when we're planting wheat as well. It might be a little bit more challenging to quantify the effect in some cases, but you put them all together and there's no question that there's better wheat to be had.
Right. Yeah, and when you get better corn and soybean yields out of it in the good years, and even better, 30% better corn and soybean yields in the bad years, yeah, it all sums up pretty nicely.
Mm-hmm.
So Dave, thank you so much for sharing this research with us today. Deb, thanks for sharing your thoughts as a CCA, and this has been a fun conversation to have. It's great to be able to talk about things that have been going on for 40 years, 25 years. It just doesn't get to happen very often. And so thanks for both being part of this conversation. Yeah, Deb.
Thank you.
I think if I could just add, Cameron, that these long-term rotation trials, I think they're fairly unique. I don't think there's a lot of them in North America or globally, and you know, we learn so much from them. As an agronomist, I'm always following what Dave and previously Bill Dean were doing with these trials, and because there was always a nugget you could pull out of there that you could take onto farm with a grower, with a client, and I don't think everyone has access to this sort of detail and this long-term study, and I think we're fairly fortunate here in Ontario to have two.
Mm-hmm.
So kudos to Dave and the University of Guelph and all the other partners, GFO, that are involved in these.
Thank you, Deb.
Absolutely. Yep. Well said, Deb. Okay. Thanks everybody for tuning in.
Thanks.
And we'll catch you next time.
Okay.
Bye.
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 Thank you all. That was great. Good discussion.
Yeah.
Yeah.
Piece something together out of that.
I think you have lots to work with, Paige.
Yeah, no, and just on behalf of Grain Farmers of Ontario, guys, thanks for participating in this and this joint venture between Soils Like Guelph and ourselves. Definitely know our members are going to be thankful for what you guys are doing and the research that you guys are doing and your input on the research and what's going on in the research plots too. So